Welcome to lesson 6 of chapter 8, Advanced Enum. Chapter 1, back in the days, you've learned how to create generic function, classes, and structs. Chapter 5, you learn how to create generic protocol with associate type. In this lesson, you will learn how to create generic enums using associative value. Welcome to Learn Swift with Bob. Today in this lesson, let's talk about generic enum. Here's a problem statement. A little more complex associative value. Well, let's take a look at what's happening here. Well, I'm just going to create an enum for you right here. So let's say we have an information enum, and again, we learn about generic code. Generic code you can apply to structs and classes and functions, and here we go, apply to enums as well. So the only thing you have to do is put this TU. We can have multiple placeholder type, which are called E, TU, Z, Bob the developer, whatever. You know, you can literally name those if you wanted to, but we have to define T or U later down the road, right? So here we go. Let's try to make an object like this. Information.name, Bob. But it's going to complain the generic parameter U could not fit in for, well, here comes the problem. What do you think about that? You probably know the answer right away. Again, when I have this kind of problem, you know what to go back to, refer to the very fundamental principle when it comes to Swift. Every single thing has to have a type defined before you can compile to a machine code. So what's happening here? So information.name, which is T in this case, is being inferred as a string value based on what you enter, right? Type is based on the value. They sound very intuitive, the principles, but you know how it exists. It applies to everywhere we go to. So here we go. We have Bob. But what is U in this case? U is not being inferred. There's no value that allows you to infer what U is, or neither. You're not telling what U is in this case, but you're working with this information. So you have to define U is if you want to use this enum. So this is how you go about to solve this problem. So again, there are two ways to do it, right? Just like struct, you can explicitly tell the type of both by like this, string and int age 20 right there. So now the T is being defined as string value and U is defined as int. Here we go. That's how you do it. It always goes back to the very fundamental we learned in chapter 1, lesson 1 right there. Okay, we'll learn about how generic enum can be useful when it comes to error handling in the next lesson. But let's move on to a little more interesting stuff. So we've been using optionals all the time. So we were able to create an optional value or type like that, just like that. Okay, so we had to kind of learn how to unwrap it to normal type, right? But here's the thing. In fact, optionals are also, well, this is exactly how you create an optional value like that. So explicit optionals and optional, and this is something like a structure. It could be enum, it could be what do you call that? Structs, it could be classes, but you're some sort of a initialization right here, right? But in fact, let's see if that works though. Let's try this. Explicit optional and the bang right there. See if that works. Oh, it works. Oh, it works. Oh, it works. So that means this is actually legit optional right there. But let's click on this. Go to definition. Oh, cool. What is happening here? Enum, public enum, optional, wrapped. So this is like T, the placeholder type, which is not defined yet, is defined later down the road. Oh, it's noisy out there. We have an optional here. And then there are two cases available, which is none. There's no value associated with it. And this should be nil in this case, right? Typically using written nil, and then you have some, which is unwrapped, and you have public init, which is we are using right now. So when you do this part, what's happening is you're making an enum object of an optional type. Okay, that's it. So you might wonder, how the heck is this even possible to create like this? I don't know. It's like you asking you, there are two ways to create a string here in this case, right? You can create a string like this, right? But you can call it a string like this. But for me, if you ask me, how do you How is it possible that this is being initialized with string value? Well, you have to understand this part. Swift is like a microwave again. There are certain functions and rules that people have designed. The microwave, the architectures and engineers have designed the microwave. And for Europe, we have the users, right? We're the users of the language or the microwave. So we have to kind of follow the rule. And then when they follow the rule, internally behind those microwave electronics, they automatically make an object, talk to the RAM, CPU, whatever. So same thing here, same thing. What's happening here in this case, Swift is actually like a microwave. We follow their certain rule. It does provide way more buttons or more customization than the microwave itself, but it's still, we have to follow the rule. So this is something that C++, if you really want to know how it works, I think you kind of have to learn C++. Go to their open source library or project, download it, and then try to see what's up. Probably I don't even know how to do that. So I know how to use Swift, but I don't exactly know how it is created. I think you probably need a lot of experience in computer science, and I don't really have that much yet. But I know how to use it very well. So here we go. So that's what's happening here. So this is more like this is creating an optional type, but this is internally what's happening here. Internally, I don't exactly know how to do this. You use custom operators time to time. For example, this is explicit optional. Now, this is a custom operator we're going to learn in chapter 10, but I don't exactly know how when you create this part, it turns into this. Probably it's done written by C++, the internal part. Okay. So we can create our own optional. In fact, let's have a little fun here. So let's create custom operator. So again, just like my optional t value here, you can define later down the road. And then we have nil and sum here. Okay. Init value, enter any value, and self equals, but you don't need self my optional because you can infer the self has to be my optional type. So here we go. We can create an object like this, my optional Bobby. Okay, that's what's happening. But do you think it's gonna work when you have this exclamation mark here? It's not gonna work. This is a custom operator. So right, this is non-optional type. Right? You cannot do that because this is your own custom enum type. This operator, this bang only applies to the original optional type. Well, this bang is actually like a custom operator. This is an operator like a function, but we're gonna learn how to design a function like this in chapter 10. So I know you guys are very excited about this. Just wait for me. I'll get you there soon. But do you think you can do something like this? If let, like value my optional, my optional, like that, do you think it's gonna work? It's not gonna work because again, this is like this syntax is like a microwave. It's like an else if, switch statement, enum. Those are like rules that Swift engineers have designed this language to be. So we kind of have to follow their rule. And then when it comes along with that rules and structure, they provide some sort of methods like this, if let, but we cannot create our own. Yes, we can a little bit by learning how to do custom operators, but they're like very small things like question mark, equal signs, but not like this entire thing. We cannot create like a switch statement or guard statement, stuff like that. It's hard. You have to learn about C++ in order to do that, or create your own language, which I don't know yet. Yeah, that's it. I wanted to take you a little bit of experience with what enums are and how optional uses enum to get the value out of it. Okay. So when you are converting, for example, when you have a bang if let statement, what's happening here is you have a value stored within sum, right? Within here. The associated value, trying to take the associated value from the optional type. Okay, that's what it means to unwrap an optional type. You're getting the value out of it. And it could be nil. If you try to get something value out of none, it's gonna crash because this is nil. But if there's a value, there's a value for it. Okay, so see you guys in the next lesson. Keep learning. I know this was a little more learning about how Swift is designed in a way that allows us to use optional. But in the next lesson, I'm going to talk about how to do error handling when it comes to how to error handling with Enum back in the days. But we'll learn about enums, and keep learning, and see you in the next lesson. I think you're very, very excited about this. Boom, we've learned how to create generic enums by using associative value. We've also discovered that optionals are enum with associative value that contains two cases. One has contained the value and contains nil case. When you work with generic enums, when there's more than one type, you have to define the rest of the type explicitly. The next lesson, you will learn how to use generic enum along with associative value to do error handling, which was used back in the days before Swift 3. See you in the next lesson.